Okay, next up in our tour of fractions, we're going to start multiplying them. Okay, and this is perhaps not as hard as it sounds. This is actually in many ways easier than what we did on adding and subtracting. Okay, so I've got a wee picture to show you first of all. And what we've obviously got here is we've split this into quarters. So there's a couple of things I can show you here. Okay, the first thing I want to look at is if we wanted to find, and this is a simple, very simple question, a half times a half. Right, first thing to note is that if we say a half times a half, what we actually mean is a half of a half. And that's going to be important later on. Okay, times and of a are just the same when we're dealing with fractions. So if you ask for a half of a half, it just means a half times by a half, and vice versa. And you can use that to help you if you have a diagram like this, because what we're basically thinking of here, okay, if I looked at this whole part here, this is obviously a half. And if I wanted half of it, then obviously I've just got this part. And we can know by looking at that pizza shape, that is obviously going to be a quarter. Right, we don't want to have to draw this diagram every single time that's going to be a half, especially when we're dealing with some of these questions down here. Okay, so what we want is a kind of a mathematical way of being able to do this. So the connection here is the fact that what we've done is we've taken the two top numbers and we've multiplied them together, and then we've taken the two bottom numbers and multiplied them together. And that's given us our overall answer, okay? So a quarter comes from 1 times 1, which is 1, and 2 times 2, which is 4. Okay, so similarly, if we wanted to do something like a half of a quarter, okay, which is obviously just the same as a half, times by a quarter, then we can take this, we can see what we've got in terms of a quarter here. If I was to split it in half again, okay, then this shape here, this space that we're left with, is just an eighth. Okay, and that's come about again from the fact that 1 times by 1, so the two top numbers multiplied together gives me 1, and then the two bottom numbers multiplied together gives me 8. Okay, so we can take any two fractions, and we could take more than that if we needed to, and multiply them together by basically times in the numerators, the top number together, and then times in the denominators, the bottom number together. Okay, so we'll look at a few more of these. So we've got these three questions here. We've got 3 quarters times by 1/5. Okay, so all we need to do straight away is take the tops and times them together, and that's going to be the top of our new fraction, and then take the bottoms and times them together, and that's going to be the bottom of our new fraction. So 3 times by 1 on the top, and then 4 times by 5 on the bottom. Now you can write it like this, you don't have to write it like this, you can just go straight to this point, which is going to be the answer. 3 times 1 is just 3, and then 4 times 5 is just 20. Okay, right, as with all fractions, if we get to this point, if we get to our answer, and we could simplify it, then we want to be able to do that. So I'm checking 3 over 20, okay? So I'm checking both of these numbers. Is there a number, apart from 1, that divides into both 3 and 20? So there's not in this case, so I can leave it as it is. That's my final answer, okay? But for further questions, and it's going to happen in both of these two, okay, we might be able to simplify at the very, very end, okay? But don't worry about the numbers. You're still just going to multiply the tops and then multiply the bottoms, okay? So 5 times 2 is going to be our new numerator. 6 times by 3 is going to be our new denominator. 5 times 2 is 10, and then 6 times 3 is 18. Okay, so we're looking at that. We're trying not to leave it if we can simplify it. And both 10 and 18 both divide by 2. And when I divide them both by 2, okay, and as long as I'm doing the same to the top and the bottom, then this is fine. I could divide by anything as long as the top and the bottom both divide by that number. I don't want to leave a decimal. Okay, I want to be left with a whole number, and 10 divides by 2 to give me 5, then 18 divides by 2 to give me 9. Okay, if I look at that again, 5 and 9 don't divide by anything other than 1, so I can leave it as that, okay? But it's simpler. Obviously, these two fractions at the end here, they're both the same quantity. Remember I said that in terms of fractions before. They're the same quantity, but obviously 5/9 is simpler, it's easier to deal with, okay? If I had to do a multiplication with 5/9, okay, it'd be much easier than doing a multiplication with 10/18. Okay, right, so on to the last one. Still exactly the same. Take the tops, times them together, and then take the bottoms and times them together. So we've got 7 times 3 on the top, and we've got 9 times 10 on the bottom. 7 times 3 is 21. 9 times 10 is 90. So we're going to get slightly bigger numbers here, but we can still deal with them. Okay, and again, we can simplify this. So you need to know your times tables. So these don't divide by 2, okay? The temptation is to just divide by 2 every single time, but 21 doesn't divide by 2 without leaving a decimal. However, 21 and 90 both divide by 3. And when I divide them both by 3, I get 7 on the top and I get 30 on the bottom. And then I can't simplify that any further, so that would be my final answer.